Here we go with this. We've given two conditional probabilities for this question. And ready here. Um, so if B happened, then the probability of A happening is 70%. If B didn't happen, then the probability of A happening is 0.5. And we know the probability of B happening. Now we could go with a Venn diagram as we did in question 1, but we could also try out a tree diagram. So what we've given here is we are given the probability of A, so the non-conditional part. Oh no, that's what we're trying to find out. Sorry, we're given probability of B and not as a conditional. So that's what we always have to do as a tree diagram is we start with the non-conditional probability. So we know the probability of B happening is going to be 0.4, 40%. So then the probability of B not happening has, B either happens or it doesn't. So this has to add to 100%. So 40% minus 100% gives us 60%, 0.6 as a decimal. So we've got those branches. Now we can use these conditional information. So if B happens, then the next thing is either A will happen or it won't happen. Right? A happens or A doesn't happen. We know that this given B happens, we're here. So the probability A happening is going to be 0.7, 70%. Probably B not happening, or sorry, A not happening is 0.3. And then what we can do is use the multiplication principle. We don't care about A not happening because what we're trying to find out is what's the probability A happening. So we can multiply along this line 0.4 times 0.7. Multiply those, and what's that going to give us? That gives us the probability of B intersect A, which is 4 times 7 is 28. So that's 2 decimal places, 0.28. Likewise, down when B doesn't happen, so that's this one here, given B didn't happen, what's the probability of A? And either A happens or A doesn't happen. Probability of A happening, given that B happened, or not B happened, is 0.5. We have a 0.5 here. We also have a 0.5 here. We're not going to use it right away, but if we needed to, we could. And again, we use the multiplication principle, but this time we're going to take 0.6 times 0.5 because this is the pathway we want. We're going to multiply those two, and that's going to give us the probability of not B intersect A, and that's 6 times 5 is 30, so 0.30. Now these other ones we don't need to get because that would be the probability that A didn't happen, and since we want the probability of A, these two intersections, the intersection of A with B, and then the intersection of A with all the stuff that's not in B, that gives us everything in A. So all we really have to do now is add these two together. 0.58, just adding using a tree diagram. And that's our answer. Let's see. Switch over to this. There we go, 0.58. So you check the answer in the back. Very good. And so we can use this one, question 6 in Bayes' theorem. Jump a little bit, but it says use this information in question 2. So while we're here, let's go ahead and do this one. We want to find now the probability of B given A. Well, the part we're going to do is we're going to, again, they recommend using a tree diagram. Well, we're going to do the same thing, but we've got to create a different tree diagram. Um, everything we found out up here is good, but now we want the probability that A happened first. Um, and so we need to make that tree diagram with the first branches coming that either A happened or A didn't happen. And we're going to use our information here that the probability, right, this is what we got here, probability that A happens is 0.58. And so we could calculate probability not happening, A not happening is going to be 0.42. 100%, 58 minus 58% gives us 42%. And so now, though, what are we trying to find? Given that A happened, so we're really only interested with this, what now is the probability that B happened? There's not B down here. But we don't know this. That's this part here. If we did, we take 0.58 times this and we'd get this. But what we do know is that if we multiply these two together, we go along this path and multiply these two, we will get the probability of A intersect B, which is also the probability B intersect A, right? We've got that up here, which is this number right here. This is equal to 0.28. So what we have is 0.58 going forward. We multiply that by the probability of B given A, we would get 0.28. So to solve our question here, to find out what probability of B given A is, we simply need to divide by 0.58 on both sides. And we can do that, 0.28 divided by 0.58, and we get 0.483 if we round that to 3 decimal places. Just like to make it a little nicer. Okay. And that's question 6, and we go see our answer is 0.483. So we can use these tree diagrams, but you could have also used Bayes' theorem, but this gives us a visual way to work through it and not having to memorize any formulas. All right, thanks.